So logic is one of those things in geometry that doesn't really seem to fit, but it has to do with making an argument for something. And in geometry, sometimes you have to prove what you're saying by using a logical argument. And so that's what logic allows you to do. Well, the logic that we learn for this class has to do with manipulating a conditional statement. All right, so a conditional statement is a statement with an if and a then. So if this is your conditional statement, it says, if you work hard, then you will pass geometry. All right, conditional statements can be true, they can be false, like this is true for some people and probably not true for others, and that's fine. It doesn't really matter whether it's true or false. What matters is that you can manipulate it to make it say what you want it to say. All right, so a conditional is just a statement that has an if and a then. Now, a converse is where you take the conditional and you flip it. So I'm going to write flip. Because what you did was you take the hypothesis part and the conclusion part and you flip them around. So it will say, if you pass geometry, then you worked hard. So I just took the hypothesis and the conclusion parts and I flipped them around. The next type of statement we're going to look at is, as soon as I can get my mouse to work, there we go, is an inverse statement. And an inverse statement is where you leave things in the order they were, but you negate both the hypothesis and the conclusion. So you add nots to them. So I'm going to keep it in this same order, but I'm going to make both of these statements a not statement. If you do not work hard, then you will not pass geometry. So these nots are what make this the inverse. So the converse you flip, the inverse you add nots. The last one that we have to do is called a contrapositive. And a contrapositive is where you do both of these things. You take the original conditional statement, you flip it around, and then you add nots to both parts. So you say, if you do not pass geometry, then you did not work hard. So we have nots, and we flipped our things around. So for contrapositives, you do both. Now notice that all of these have an if and a then. All that we're doing is taking the hypothesis part, let me go ahead and label that too, hypothesis, and the conclusion part, and we're manipulating them, either flipping them around or adding nots. All right, there are some symbols that are associated with logic too, so we're going to talk about the symbols that are associated with logic. I can use the letters P, Q, R, S, T, any letters really, to represent an entire hypothesis and an entire conclusion. Like for instance down here, I say let P represent I have a laptop. So now instead of writing out I have a laptop, I can just write the letter P to represent that whole statement, that whole phrase. The symbol that we use when we want to make something a not is called a tilde. It's just that little squiggly line that you see on top of the congruent sign. The symbol that we use for if and then is just one arrow. This arrow goes in between the hypothesis and the conclusion, and you only have to draw the arrow once, and it means both the if and the then. This symbol right here, an arrow that points in both directions, means if and only if. The thing that looks like part of an uppercase A is an and. The thing that looks like a V is an or. And the three dots mean therefore. All right, so we're going to just look at a really, really quick example. It says, let P represent I have a laptop, and let Q represent I want a tablet. All right, and I have two sentences that I'm going to represent in symbols now. The first one says, if I have a laptop, then I do not want a tablet. The first thing I notice is that it has an if and a then in it, so I know that it's going to need an arrow. All right, the hypothesis part is what comes after the if. It says, I have a laptop. Well, I have a laptop is going to be represented by the letter P. So I'm going to put a P where the hypothesis goes. And then the conclusion, the thing after the then, says I do not want a tablet. Well, Q is that I want a tablet. So if I want to put that I do not want a tablet, I need to make Q negative. And the way you do that is by adding the tilde or the squiggly. So you would put a tilde and then you would put a Q. That's how you would represent if I have a laptop, then I do not want a tablet. And we have one more to go. It says, I want a tablet, therefore I do not have a laptop. The first thing I notice is that it does not have an if and a then, which means it is not getting an arrow, because this is not a conditional statement. This is just a statement. The first part says, I want a tablet. Well, I want a tablet is the letter Q. So I'm going to put a Q. And then it says, therefore. Well, the symbol for therefore is 3 dots in the shape of a triangle. So I'm going to make that symbol. And then after therefore, it says, I do not have a laptop. Well, I have a laptop is P. So I do not have a laptop would have to be not P. And that's how you use symbols to represent logic statements.